In this tutorial, we are going to talk about concept of limit. Limit is a fundamental concept in calculus, and we use limit to define derivative. Let's start with a couple of notations. This notation is used for x approaches a. The second notation is x approaches a from right side and x approaches a from left side. When we say x approaches a, that means x is getting close to a, but x is not a. X is in the neighborhood of a. X is between a minus epsilon and a plus epsilon, when epsilon is a positive number and x is not a. X approaches a from right side means x is between a and a plus epsilon, when epsilon is a positive number, and similarly x approaches a from left side means x is between a minus epsilon and a when epsilon is a positive number. We say limit of f of x as x approaches a is L, and we write it using this notation. Let's explain the meaning of limit of f of x as x approaches a equals L. Limit of f of x as x approaches a is L, provided that we can make f of x as close as possible to L for all x sufficiently close to a from both sides. And x cannot be equal to a. Similarly, we define limit of f of x as x approaches a from right side equals L. When f of x can be as close as possible to L for all x sufficiently close to a from the right side. That means x is greater than a in this case. Limit of f of x as x approaches a from left side is L, provided we can make f of x as close to L as we want to for all x sufficiently close to a from the left side. One more time, right side means bigger, left side means smaller. Let's take a look at this example. Graph of a function is given. We want to discuss the limit of the function at x equals 1. When x approaches 1 from right side, f of x is getting close to 2. Therefore, limit of f of x as x approaches 1 from right side is 2. And when x approaches 1 from the left side, when x is smaller than 1 and is getting close to 1, f of x is getting close to 1. Therefore, limit of f of x as x approaches 1 from left side is 1. As you see, the right side limit and left side limit are not the same. The limit of f of x as x approaches a exists if and only if both the right and the left side limit exist and they are equal to each other. Therefore, in our example, limit of f of x as x approaches 1 does not exist. Let's look at the next example. When x approaches 4, either from right side or left side, f of x approaches 8. Therefore, limit of f of x as x approaches 4 is 8. Let's have a couple of numerical examples. The first one is limit of f of x when f of x is 2x as x approaches 3. We have a table of values here. We calculated the value of the function at 3.1, 3.01, 3.001 for the right side limit, and the value of the function at 2.9, 2.99, and 2.999 for the left side limit. As you see here, when x approaches 3, from either side, f of x is getting closer to 6. Therefore, limit of 2x as x approaches 3 is 6. If we want to explain this without using the table of values, we say when x is getting close to 3, 2x is getting close to 6. The next example is a right side limit when x approaches 3 from the right side, and f of x is 2x2 minus 1. Again, we use the table of values. We calculated the value of the function at 3.1, 3.01, 3.001. We are looking for the right side limit. That's why we used numbers a little bit more than 3. With this calculation at 3.1, f of x is 8.61, 8.0601, and so on. As you see, when x approaches 3 from the right side, f of x is approaching 8. Therefore, limit of f of x as x approaches 3 from the right side is 8. It's good if you make similar table for limit of f of x as x approaches 3 from the left side and see it is also 8. Our next example is limit of f of x as x approaches 1 from the right side and the left side when f of x is 1 if x is bigger than 1 and negative 1 when x is smaller than 1. The value of the function at 1.1, 1.01, and 1.001 is 1. The values of the function at 0.9, 0.099, and 0.0999 is negative 1. Therefore, limit of the function as x approaches 1 from the right side is 1, and from the left side is negative 1. This means limit of f of x as x approaches 1 does not exist. We use this notation to say the limit does not exist. As you see, the value of the function at 1 does not exist, and we are not interested in that value, as we are not interested in the value of the function as x approaches 3 on first example and the second example. The next example, f of x is 4 when x is not 3. It is 1 when x is 3. We are looking for limit of f of x as x approaches 3 from the right side, left side, and limit of f of x as x approaches 3. Again, we use a table of values. We'll see when x is 3.1, 3.01, 3.001, 2.999, and 2.99. The value of the function is 4. We are not interested in the value of the function at 3, although we know it is 1. The right side limit is 4, the left side limit is 4. They are the same, therefore the limit of f of x as x approaches 4 is 4. Let's recap We talk about the meaning of x approaches a from the right side, and x approaches a from the left side. When we say x approaches a from the right side, means x is bigger than a, left side is smaller than a. When we say x approaches a, x is close to a, but x is not a. In all three cases, x is getting close to a, and x is not a. When we say limit of f of x as x approaches a equals L, that means f of x can be as close as we want to L for x is close to a. We defined limit of f of x as x approaches a from the right side and also from the left side. Let's have one more example. Then we want to find limit of f of x as x approaches 1. When x approaches 1, x2 is close to 1, therefore x2 plus x is close to 2. In calculation of limit, the best candidate for finding the limit as x approaches a is always a. Although x cannot be a, but it gives us some idea about the limit. Thank you.